We're now on question number 2, and we're still working on organic chemistry. So it asks, the diagram below shows the structural formula. So it shows the structural formula of a hydrocarbon. A hydrocarbon yedu inenge ngori ne H and C, which is hydrogen and carbon. So this is the structure formula yatabata piwa, which is here. So now the question now goes, what is the name given to the homologous series of the which the hydrocarbon belongs, right? So the homologous series which the hydrocarbon belongs, takudzokera pane the hydrocarbon redu ratinaro. Anditika, if we can check the hydrocarbon redu, we find out we have this thing which is a carbon double bond, or a CC bond. So normally when we find those CC bonds, tinenge ma alkenes. So alkenes are the ones that have the CC double bond. So the name of the homologous series to which that belongs to is what? Is an alkene. So we have alkene here. Then second question, write down the molecular formula of the hydrocarbon. Saka we want to work at the molecular formula for the hydrocarbon. Isusu tangatapiwa e formula is a structural formula, but now we want to work at the molecular formula. In other words, in the molecular formula, trungopa only the number of carbon as well as the number of hydrogen anenge arimo. So we have to count, right? So pa totima tine C, right? Saka takunoverenga ma C edu takuti 1, 2 and number 3. So we have 3 ma C edu. Then as well we have my hydrogen. My hydrogen edu mangani. It's 1, 2, 3, 4, 5 and 6. So we have C3H6. So C3H6 now becomes our what? Our molecular formula. So it's what? C3H6 per answer edu up. Then tovataenda pane the next question, number 3. Calculate the percentage composition of hydrogen. So apa patinoda calculate the percentage composition ye hydrogen. Kuti hydrogen yedu its mass over the total mass of the compound yese inenge irichi, it's in its percentage. Saka for us to have that percentage composition, takuti percentage composition ye hydrogen is now going to be equal to the hydrogen yedu all over the what? The total what? Compound. Then all of it will multiply by 100%. So trukuti hydrogen yedu tukunotasa mangani, right? Because remember tatinichi C6, then we have C3H6, right? So trukuti ma hydrogen yedu mangani 6, right? Saka takuti 6 by what? By hydrogens. Then all over tati isusu the total compound yedu ina C3. Saka takuti 3 edu machi ma C plus 6 machi ma H. Then all of it takuti multiplied by what? By 100. So now taku no replace ma C and ma H edu with their relative atomic masses, right? Saka hydrogen in a 1 and then carbon yedu inenge neshi 12. Saka takuti 6 by what? By 1 all over pazasi tina 3 by apapa it's carbon. Saka carbon yedu inenge 12, then plus 6 by 1. Then all of this chavatash times are by 100%. So tash times are by 100%. Takuchibva taenda pani calculator yedu, and then takuti isusu inobva yaita equal to 6 all over, then takuti 3 by 12 inondipa 36. Yatipa 36 toti 36 here plus 36 here plus what? The other 6, then we get 42. So it's 6 over 42 multiplied by 100. And then taku finalize the answer yedu tinenge takuti isusu 6 divided by 42 then all of it takuchiva time multiply by 100, and then we get 14.29. so we have 14.29. so 14.29% yedu can also be written as what? As just approximately 14%. so that's the percentage composition of what? Of hydrogen, the hydrocarbon redu. Then we look at B. The hydrocarbon in the diagram was placed into a test tube and drops of bromine water was then added. Saka isusu kana tiri pama exams ndizvo tiri kuti isusu paunonzi the hydrocarbon, whenever you find wakuita zvine chekuita nema reactions, you look at the reactions in terms of the homologous series in which it belongs to. So apa rather tinenge tangoti the what? The alkene. So the alkene in the diagram, since taiona kuti is an alkene, right, was placed in the test tube, and then drops of bromine water was what then? Was then added. And it saka ya edwa kudaro. First question of that is state and explain the observations in the experiment. And it so the observations that we get is that bromine yedu it's brown in what? In color, right? So now chintu kanda chekuti bromine water paino edwa ndizvo it decolorizes. Saka the observation yedu yatichaona, observation will be that what? Bromine decolorizes from brown to colorless. And then question idanga to state, and it saka kapa state apa we get the mark for stating, right? And then takuda kuenda pane explanation. Saka the explanation yedu yaya kuti why did it turn what? Colorless. Why was it what? Decolorized. Because tineta kuti explanation yedu is because what? Alkenes decolorize. Alkenes decolorize what? Bromine water. Or just bromine. Saka that would be what? Our explanation for the question. And then we want to look at the next thing in our question, which is we have number 2, which is B2. Determine the number of moles of hydrocarbon if 13 grams of the hydrocarbon was used. So remember the hydrocarbon is what? Is C3H6. Is that okay? So now, kanata determine the number of moles. Remember, the number of moles yedu kuti determine, we have to firstly find the data that has been given, right? Saka mass yedu of the hydrocarbon, which is mass of what? C3H6 is equal to what? 13 grams. And the other thing jata piwa is the hydrocarbon's formula itself, and it can. And one of the hydrocarbon molecular formula inotipa the MR. So the MR of what? Of the C3H what? 6 is equal to ndoya tambo calculator in the previous, where we said it's what? 3 by what? My carbon plus what? 6 by machi by my H. And in the previous we got what? It's 42. Saka tine zvinu 2 zvatinazvo. We have our mass and we also have our relative molecular mass, right? So formula yedu number of moles, number of moles is equal to let me just get this right. So we're saying the number of moles of what? C3H6 is equal to saka it will be what? Mass yedu over what? MR. So in other words, mass yedu is what? 13 yedu grams over what? 42. So then we punch that into our calculator. then tap puncher. In our calculator we have 13 divided by 42, then we get 0.3. So it's 0. What 30 so 0.30, so we just say 0.30, or we approximate to 0.31. So that those are the number of what moles that we have. So this one or this one, it was going to be okay. Another person was just going to say 0.3 without the 0 moles, or 0.31 moles. So I can do my number of moles at 80 now, and then that wraps us up our question number 2.